Welcome y'all, this is going to be lesson 57 for algebra here. This starts on page 232 in your textbook and it's a very short introduction. They give 3 examples. I'm going to do 2 of them here on the board for you. If you have any questions, hit me up in the comments. But this lesson is on the addition of algebraic expressions with negative exponents. Now that sounds terrifying, but if you do one little step first, it'll make things a lot easier. That first step is to take the original expression and rewrite it in a new form. That form will have no negative exponents. So, ax to the negative first, we can write in a new form. All we got to do is move that negative exponent down to the bottom, make it positive. So this will actually become a fraction. We'll leave a on the top. We'll move x to the negative first to the bottom, and it will just become x to the positive first. So these are the exact same thing, it's just 2 different ways of writing the same thing. We'll do the same thing with the y to the negative first. We will move it to the bottom of a term. Remember, anytime you move everything from a term to the bottom, you leave a 1 up top. So we'll leave a 1 up top, we'll move y to the negative first to the bottom, and it will just become y to the first. So again, these are the same thing. These are also the same thing. They're just in a new form that's easier to work with because now there are no negative exponents. Now we work this out like we always did. We just get a common denominator. In this case, the common denominator is x, y. So we will do that. We will put x, y as our common denominator. For this first term right here, it has an x. It needs a y. So we're going to multiply top and bottom by y. A times y, x times y. We'll put that in our answer in a minute. Over here, we already have y. We need x. So we will put an x in the numerator and an x in the denominator. Now we have a common denominator, x, y, x. They're the same thing. Order doesn't matter. They both have x. They both have y. These are now common denominators. And so in our answer, which has the common denominator, we will just write an addition problem for our numerator. We'll have a times y, which is ay, plus 1 times x, which is x. So we get ay plus x over xy. Now, over here, like I said, I'm skipping to example 3, but on this one, we're going to do the exact same thing. Any negative exponent, we'll just move to the bottom and make the thing a fraction. So in this first term, x has a positive exponent. Remember, if it doesn't have 1, it's just 1, so it's x to the first. We'll leave it on the top, x. We will move a and y down to the bottom, making their exponents positive. So this will become a squared. This will become y. And then we'll do the same exact thing over here. Since this first one is not negative, we'll leave it on the top. Since this one is a negative exponent, we'll move it to the bottom, and we end up with a over z. So once again, these are 2 different ways of writing the same thing, and these are 2 different ways of writing the same thing. We've just put it in an easier to work with form. And now we do just like we did over here. We get a common denominator. In this case, the common denominator will be a squared y, z. We just put it all together, a squared y, z. And we do just like we did on the other one. Since this term needs a z, we'll put 1 in the numerator, 1 in the denominator. This term has z, it's missing a squared and y. So we'll put an a squared y in the numerator and an a squared y in the denominator. We now have a common denominator, a squared yz. We're just going to simplify our numerator. We have xz plus, over here we've got a times a squared, which is a cubed, and we have y. So there's our answer for that one. Xz plus a cubed y over a squared yz. So hope that helps. If you have any questions, like I said, just hit me up in the comments, and I'll see what I can do.